Hello, everyone. Welcome to another LSA CPD. Today we have Bob Prewett of Prewett Bisley Architects. For those of you who it's the first time coming to CPD, I'm just going to give a quick overview of how they work. So we have a guest speaker speak for around 30 minutes, and then the aim with these CPDs is to try and foster discussion amongst this network of professionals and architects and other professionals related to that discipline. And so we try to give that equal billing to the talk itself. So during the talk, do put questions into the chat. I can read them out after, or if you're feeling really confident, you can unmute yourself, turn on the camera and have a conversation as well. So today we have Bob Prewett, as mentioned. I've got my bio up here. So in this CPD, Bob will discuss his practice approach to intervening in existing dwellings and what his firm believes constitutes retrofit. He will explain how a fabric first alongside heat pump technology approach offers the potential for deep low carbon retrofit and how they are increasingly taking into account embodied carbon as a part of a whole life carbon approach. So without further ado, we'll hand over to Bob, who's with us. There he is. Great.
Hi there.
Thank you, Bob.
Thank you very much. I'll share screen. Does that come up okay?
Yeah, that's great. Thank you.
Brilliant. So thanks for the introduction. I'm going to talk about retrofit, as you said. And I thought I'd kick off with a graph because there are more to follow. So this talk is part sort of personal reflection, part views about what I've learned about retrofit and how important retrofit is to UK carbon emissions. And I'll talk mainly about a case study, but I'll try and reference that back to sort of bigger kind of strategic aims as well. Okay. So thanks very much for joining us and for coming along to listen to me. I'll try and aim for about 25 minutes, and please do put questions up on the chat. I hope you've got plenty. Whether they're challenging, I'm quite happy to sort of take all sorts. So I'm going to talk about 5 things. I want to say a little bit about context. I'm talking about a project which we did 10 years ago, and which we're sort of reflecting on a bit in the office at the moment, because of how it's sort of affected what we've done. And then I'll talk about 2 and 3 are really the case study, the particular project, and what we did. 4 is about sort of going back and trying to measure how it behaved and did it behave. And number 5, that's sort of trying to reflect back to the bigger picture. So the context of the project, we took the project on in 2008, which all the talk at the moment about sort of economic crises, people keep referring back to 2008 as being sort of the last time we experienced a major sort of tectonic shift in our economic being. And the project we took on before the crash took place. But the direction of the office at that point was very much sort of new build, probably new build passive house, and probably looking to build small collections of homes. We'd won a Europan competition, and we'd had other opportunities to build larger scale housing, and that seemed to be what we were about and what we were going to do. But between the project I'm going to discuss and the events that took place afterwards, our trajectory and my trajectory changed somewhat. It was also a time when I think people were waking up more to climate change, and were realizing that whatever we built in terms of new builds, existing buildings posed sort of a fundamental problem in terms of their carbon emissions and their lack of insulation. So this particular bit of text I used to use with this when I spoke about this project some time ago, and it was I grabbed it in about 2010 from the Energy Savings Trust, but it pointed out succinctly what people had sort of come to realise at that time was that the aim at that point was to reduce CO2 emissions by around 80%. I think now the ante has been upped somewhat. But households back then accounted for about a quarter of UK CO2 emissions, and approximately 3/4 of those homes will still be with us in 2050. So when we took the project on, this stuff was sort of dawning on us that intervening with existing buildings was very important. And it's this sort of inescapable challenge, which we've managed not to do an awful lot about nationally for 10 years, but it doesn't go away nonetheless. Sorry, it's a bit of a fuzzy image, but this slide is a pie chart from DEC, as it was called then, the Department for Energy and Climate Change, and shows that the average sort of energy use across housing, about 62% of it's for heating. That's not really changed much since then. And then the next biggest bit is for hot water. And that's, I think, is interesting as an architect, because as architects and building professionals, we have, a lot of influence on how big those two bits of the pie end up being. The lighting and appliances, we probably have a little bit less control over, perhaps a little bit on lighting, but not much on consumer electronics. So, as I say, we were approached in 2008 by a couple who'd bought a house in Hackney, at a charming, Victorian conservation area, lovely garden. But they presented us with a challenge to, I think the first words from Robert's lips when I picked the phone up was he was interested in doing an extreme refurbishment. And as I say, at the time we were focused on sort of bigger new build homes, and we were trying to actually leave this world behind us, in a way. But he convinced me that this project would be different to other kind of extension projects. It would be an opportunity to explore something more ambitious. So we took it on. And when we took it on, we sort of embarked on a world of sort of energy modeling, and we'd been doing some of this stuff for projects before, but we felt we should sort of take control of it. So we modeled the expected space heating demand and so on, for the house as it was, and we looked at the projected carbon emissions from that. And not surprisingly, space heating was the dominant factor, in line with the deck slide earlier, and then water heating using a gas boiler was the next biggest lump, and so on. So when you add up these bits of the pie, they come to about 6.5 tons of carbon a year, which, broadly speaking, you'd expect from a house of this period that's not insulated and without double glazing and so on. So this was a kind of bit of a baptism of fire into the world of sort of energy and carbon literacy, and we felt that we should take those things on and own them to take the project forward. In terms of the house itself, and what we had to work with, it was a slightly peculiar plan, quite a meanly planned house. So 2 small rooms per floor plus a staircase. And you can see the lower ground floor, the stair sort of appeared in the kitchen, and the guest bedroom was sort of accessed from the kitchen. And the kitchen sort of had very little relationship to the very attractive garden beyond, due to these sort of closet additions. And there was only one other bedroom on the first floor, part of my box room. So it's quite a, not a spectacularly beautifully laid out house. And our challenge was to sort of turn that into more of a family home. So we looked at extensions and what one can do within the world of conservation areas, which is sort of familiar territory to us by then. And the normal prescription was adding on a sort of a closet wing like this, subservient to the main form, etc. But this really only adds on sort of space for a study or a loo or a shower room, really. And we felt that if you sort of reapplied that volume full width, you'd actually get a much more useful bit of volume, and you'd also be much more efficient in terms of the heat loss area that's attributed to the floor areas. It's much more efficient thermally too. So we fought quite hard with the conservation team to let us do this, and we tried to demonstrate that it caused less impingement to the neighbours generally than the standard option. And we built a large model to try and help convince client, us and them, that this was the right thing to do. And as well as that quite shallow extension on the lower two floors, we looked at squeezing in a tiny little loft extension on top of the house to win another bedroom. And of course, that meant we had to re-engineer the whole staircase. But it seemed like the right thing to do to us. So I'll wish you through what the actual sort of proposed scheme is built now, and try and explain how we generally improved matters. So this is the lower ground floor, and you can see it's the way the stair relates to a sort of a lobby and a kitchen diner and a bedroom. It's a bit more successful than the original plan. The other important thing about the drawings is at this stage we sort of adopted this sort of system of whenever we draw insulation, we colour it yellow approach to design work, so that from a very early stage throughout until technical design, we're very conscious of where the insulation is and where it joins up or where it doesn't join up, and that as a sort of quite a simple system is kind of underpinning this sort of fabric first approach, which we adopted at the time and continue to sort of work through. So lower ground floor, much stronger connection with the garden. It's a nice, simply laid out kitchen, cupboards made from old floorboards. Upper ground floor, which is sort of the entrance floor, we sort of remodeled the entrance hallway to make it a bit more generous. Created a little study room at the front and a much more generous living room at the back, and that connects down to the kitchen dining below. You can see lots more yellow insulation everywhere. And the client was very keen on arranging good daylight, and so dual aspect on this floor makes the space really lovely to be, and even the sort of glazed clerestory above the hallway helps illuminate that space too and give the whole interior a slightly more airy feel than it did before. And then walking up past the first floor, which stayed more or less as it was originally, as a bathroom and a bedroom, but with windows carefully placed, and then up again to the loft, which is sort of perched in the V form of the roof. Probably something which we'd struggled to get through planning now, is V roof shapes are sort of extraordinarily protected in conservation areas nowadays. So quite a small room, like a little airy space at the top of the house with this lovely view over the trees and so on. And one of the constraints we had planning wise was, of course, daren't show the face of the extension to the streetscape, so that was sort of sacrosanct. But on the back of the house, we were given a little bit more rope. Most of the backs of these terraces has been changed in innumerable ways. So as well as the roof extension, we've managed to get some PV on top of that, although the level of debate that was required for that was quite tortuous. So that's a brief sort of summary of the project, and that's really all I'm going to say about kind of what we tried to do architecturally. I'm more sort of focused today on how we try to deal with the building fabric and the lack of insulation, and how we tried to sort of make up for that. So one of the diagrams we produced at planning stage, which turned out to be a really useful drawing in the end, to sort of explain the whole project, and kind of the ideas behind the whole project was this one. You can see the extension, you can see the loft, you can see internal wall insulation on the front of the house. You can see that yellow line of insulation sort of wrapping and hardly stopping. And there are a couple of little gaps there, which we corrected later on. You can see some underfloor heating on the lower ground floor, which was more or less the only heating we put into the home. Triple glazing at the back, double glazing at the front. Lots of air tightness measures and a ventilation system with heat recovery sited up here in the loft. So this summary drawing for us became what's now, I think, referred to as a whole house plan. And we tried to capture as much as possible in one single drawing. The individual bits of that whole house plan then sort of unfold like this. And so this is the front wall, which obviously we couldn't do anything to the outside of. So we were stuck with the dilemma of how to do internal wall insulation. And there'd not been very much debate until this point about internal wall insulation. And this was our sort of best go at it at the time. So the brick wall, which changes thickness as you go up the building, of course, we've deliberately designed in a cavity there to avoid the possibility of interstitial condensation. And we fitted a kind of slightly homemade but reused kit that an insulation provider was marketing at the time, which are these sort of XPS studs, which allow you to sort of create sort of wall thickness and then fill it with glass wool. And there are 3 layers of OSB board separating all of this, so limiting any possible air movement and making that whole facade very airtight. And you can see there's a window board there, a plywood window box, which is built into the wall insulation, and that houses the window and allows the whole thing to be made airtight. We took the joists out of the front wall on this project and put in steel beams spanning party wall to party wall. This was sort of a first sort of venture into the risks of internal wall insulation, and we were concerned that joists might long term be damaged if they were left in a colder, wetter wall. And so we started off with a U value of around 2. I mean, arguably that might be seen as sort of perhaps better than that now, perhaps about 1.7. And with quite a lot of wall insulation, a U value in the proposed of about 0.2. So not far from sort of building regs now. Pretty robust. And that's a sash window, a replica sash window fitted into that wall insulation with the original shutters fitted back to it. And we went with a slim double glazed unit to do each of the multi-pane panes in the sashes, with real astragals going through. That's probably something we do slightly differently now. I think we probably use different glazing products that have come onto the market since then, but this was the best we could do at the time. and gave us a U value of that window probably around 2. And the joiner who made these windows did quite a good job. We had four strips on each sash trying to make them airtight, and they performed remarkably well when we tested the house, actually. So that's the front of the house. The back of the house, which was part extension, we had a bit more flexibility on. And so, you know, this is largely new build work. So reusing stocks that we reclaimed when we demolished part of the back facade, building as a cavity wall, using thermalite blocks, full fill glass wall, quite a wide cavity, 200 mil, special cavity ties, which have just come onto the market. The use of foam glass here at the base of walls where we need structural capacity, but we're looking to avoid thermal bridging. So this was kind of new stuff for us at the time, and quite perplexing. Getting down to a U value of about 0.15. At last minute, when we got the full width extension through on planning, they forced us to accept these little returns at first floor level in deference to the neighbours' windows, and this created quite a puzzle in terms of DPM, which we tried to resolve here, and I think we were successful. But if I were doing this now, I'd be much more cautious about doing this sort of thing. Quite difficult to do this in brickwork, cavity wall construction, and remain completely watertight. But the project seems to have survived quite well. And fitting windows into walls and sort of learning how to fit windows in without thermal bridges. So trying to hang this window within the wall insulation zone. And we've actually failed a little bit. There's some minor bits of bridging here and here, but perhaps much better than what we might have done before. So big German triple glazed window, these plywood boxes built into the masonry as it went up, and no lintels going all the way through, so separate lintels on each leaf. So sort of basic kind of thermal bridge free construction. But this was all sort of absolutely new stuff to us 10 years ago, and people were only just sort of publishing this sort of stuff. So it was quite a learning experience. Another big learning experience is the whole business of ventilation and heat recovery and air tightness. So we managed to dream up a fairly simple arrangement of ducts which occur between chimney breasts and a heat recovery unit in the loft, with primary ducts quite short running to the outside. And just a little bit of maths on the side here for those people who still think that natural ventilation is superior. We felt that before the project there was about 8,000 kilowatt hours of heat loss due to sort of uncontrolled infiltration. Arguably, you could have reduced that a bit just by making it a bit more airtight. But contrast that with only 350 kilowatt hours of heat loss from the ventilation unit due to its inefficiencies, plus a little bit of energy to run it for a year. We're looking at only a spend of 500 kilowatt hours. So a saving overall of thousands of kilowatt hours and about more than a ton of carbon. So we believe that heat recovery ventilation has its place in retrofit for certain projects. They need to be quite well planned, and they work especially well in areas where the air quality is quite poor. So the filtration it provides gives you much enhanced air quality. So near busy roads and so on, really useful. That's the system going in. I confess, looking back now, not really very happy about the quality of that. It's okay, just about, but it was a first attempt, and I think the systems we install now look much more professional, and I think work probably a little bit better too. Air tightness. So again, this was sort of a big first for us. We tried to push for air tightness of better than 1. Some of you will know that building regs minimum is 10, which I think is sort of ludicrous. After 3 tests, we managed to get sort of down to about 1.2, which remains sort of still pretty good for a retrofit. We had it tested a few years ago again, and it shifted a bit to 1.4, got a little bit worse, mainly around a couple of doors and windows, but actually holding its air tightness pretty well. There's a note here about maximum air tightness for heat recovery ventilation. So back in 2010, we thought that if the air tightness were worse than 2, the heat recovery ventilation wouldn't be very efficient. It is less efficient when the building's more leaky, but recent work by the Passive House Trust sort of demonstrates very clearly that it's still worth installing, even if you don't get all the way down to sort of level of 1 and so on. So we built the project. I think the client moved in around 2010, and we started, or the client started measuring energy use, and we've got 6 years of energy use here in the red bars, so looking at annual space heat demand. Our model suggested sort of more than 200 kilowatt hours per square meter before retrofit, and afterwards it's 26, 27, 30, 25. Varies slightly each winter, mainly on sort of the severity of the winter really, but very stable, very good levels of comfort indoors, and very low and pretty close to modelled. This graph looks at carbon emissions, and again, this is the stuff on the left is the stack of carbon before, so a lot of it's heating, hot water, and then electrical use on top. This is measured afterwards, and the orange here shows the PV as a negative number, and then the next stack of blocks shows that orange sort of aggregated across the domestic electric up here. So the house is about 1.5 tons per year carbon, based on 2010 numbers anyway. Interestingly, if we applied current CO2 intensities, and if we added an air source heat pump, the carbon consumption per year would drop to about 3/4 of a ton. So edging close to sort of negligible. And this is a really simple carbon comparison over time. So the blue line looks at what the house would have done if the owners had done nothing and moved in. That's probably a bit theoretical because there was barely a working kitchen or a bathroom. But if they just moved in and heated it to some decent level of comfort, they'd have got through a lot of operational carbon over the last 10 years, some tens of tons. The orange line shows the operational carbon as measured, so it's about 1.5 tons per year. But we've added in the embodied carbon as we calculated it for the build. So there's this burp, as it's referred to by some people. So the carbon you spend doing the retrofit, doing the project, we spent about 25 tons. It's quite a high spend, and that's something I think we look to do much to cut back on there. But even then, after sort of 3 years, it's sort of in net benefit, and it's been the net benefit for sort of seven years or so. So a few concluding thoughts based on that project and our experience since then. This is a pie chart from a recent report from the UK Climate Change Committee. And I said at the top of the session, the EST number said residential was accounting for about 1/4 of CO2 emissions. It's actually dropped a bit down to 18%. mainly due to grid decarbonisation, which has reduced the sort of carbon consumption associated with domestic electrics. It hasn't really touched our heating very much because that's still done by gas. So, 18% of the pie, or if we include all buildings, almost a quarter, is still a big challenge for us as a country. The other thing that's happened in the meantime, since 2010 to now, is this graph is plotting the carbon intensity of electricity. So back in 2010 and back in the noughties, electricity was about twice as carbon intensive as this red line, which indicates natural gas. Okay, and back in 1980, it was horrendous because we were burning lots of coal here to create electricity. Here we were down. It was using gas to create electricity. Things were getting cleaner, and the last few years, with the advent of renewables, especially offshore wind, grid electricity has plummeted to the point where it's now sort of around the same intensity as gas, or probably a bit better at the moment. And then for the next 20 years, we're not quite sure where it will go. These various predictions, it'll probably get less. Whether it gets all the way to sort of zero, as some of these more optimistic curves suggest, we will find out. But this change causes us, I think, a shift in thinking for retrofit. Not a change fundamentally, but a shift. And then this graph is also important to have at the back of one's mind. So this looks at the blue line is what the grid's doing all year, which is basically sort of fairly steady load. It goes up and down during the day a bit, but broadly speaking, it's about the same. The red stuff shows heating that's going into our homes. So obviously not much in the summer, but a lot in the winter. And what's striking is that the heating load of our homes is many times that of our grid capacity at the moment. So while the previous graph would suggest we should just immediately flip from gas boilers to direct electric, this graph would suggest that might not be possible. We'd all find too that our heating bills would triple because electricity is 3 times as expensive as gas. There's a drive to shifting towards the electrification of heat, and a drive to do that using heat pumps. Heat pumps will give us the sort of efficiency, which will make the cost more comparable with gas, and it will also help bridge the gulf between the red and the blue on this slide. And then this is the penultimate slide. This one shows that most of our domestic stock is actually owner occupied. And so, so far, most retrofit activities have been focused at the social housing end of things, because it's sort of easier to grab hold of the levers on those things because one landlord owns a lot of stuff, whereas all the blue stuff is owned by lots of individuals. But our big challenge retrofit wise is to deal with the blue stuff. If we're going to retrofit 10, 20 or more million homes, then the blue needs to be dealt with. So 4 points I'd like to leave you with. They might be sort of directions or bit questions. The first one is that I still think that energy efficiency, fabric efficiency is still very much required. Perhaps not as ambitious as the project I've just shown, but I think across the board, we need to be thinking about 50% reduction in heat demand. And because some homes won't get captured at all, and some homes will be quite difficult to do, it's important that every project we should try and aim as high as possible. And that if an average of 50 we're looking for, well, some will be 0%, and some should be as ambitious as the project I've just described. Number 2, we urgently need to sort of electrify heat in existing homes. And as I say, that's probably allied with heat pumps. And And that will do some of the additional lifting, which the fabric efficiency, I think, probably won't, because I think we accept now that doing all homes to 80% fabric is a challenge. And the next point is private homes. Is that the area of challenge or opportunity? So, you know, my practice is working for private individuals on their sort of home renovation opportunities, and there are lots of other architects doing that, and there are tens of thousands of people every year in London doing major works to their homes, in many cases without doing any of the retrofit stuff. But each time a house is altered drastically, that's the opportunity to carry out a deep retrofit. And I think a little bit of push from government and a little bit of support from government, and a bit of more enthusiasm from our profession and the building industry as a whole could yield tens of thousands of much deeper retrofits quite quickly. And then the last point is really just to say, but don't forget about embodied carbon too. So especially as energy becomes less carbon intense, the carbon involved in the project becomes by proportion bigger and therefore more important. So that is a sort of final point, which I think is coming to the surface now, but it's about balancing all of these things together that will hopefully reduce our overall domestic carbon emissions. So thank you. That's what I had to say today. Jason.
Thank you very much for that, Bob. Bob, do you want to stop sharing your thing? That way we can kind of, if people want to unmute or talk, they can ask away. I'm going to read out. So put your questions in the chat. I can read them out. I've got a few ready, so you have time to formulate them in your head. But I can see you've got one already from Joanna, and they ask, "Can I ask what you think about the latest Green Deal initiative from the government?"
Probably the same as you, Joanna. It was slightly exciting at first. The warm words were good, but it was another government initiative which was rushed. The system wasn't put in place, nor the supply chain, and it sort of crashed, hasn't it? Because the system immediately fell over. So it will be interesting to see whether the government sort of learn from that and sort of create a better system and still put the funding in, because there was what was interesting was the overall amount of funding was quite attractive in terms of billions. I thought the sort of £5,000 voucher was probably a bit too small per project. I'd like to see a larger amount per project so that people can invest in something that's a bit more whole house like and a bit more useful, a bit more effective over time. And the government needs to help build the supply chain to deliver it, because it's not funded this for 10 years.
Mm-hmm. I want to ask a question as well. Early on, you mentioned using 3 layers of OSB board. I wanted to ask, how thick was that in total, and did the clients mind losing floor space as a result?
Yeah, it was quite lumpy. I think we probably gave away about 250 millimeters, almost a foot of wall insulation in a house which wasn't very big in the first place. So we did, and we continue to sort of each project calculate kind of lost floor area and look at that as a stat. On this one, I think we gave away, it might have been like half a dozen square meters of floor area, but we won back about 20 in extensions. And that was part of the conversation we had with the planning team too, to say, look, we're giving stuff away, but it's important that you support us in winning some back. So I think we were able to sort of end up net positive and with a good set of spaces. But I know for some people that's kind of immediately a scary thing.
Yes, it was interesting, because it's hard to really realise when you lose space within a room, but if you gain another room, that feels, because it's an ancillary space, I guess, or it feels a bit extra. Anyway, I've got a question from Debbie, which I'll read out. She says, thanks, Bob. What would you do differently today to reduce the embodied carbon in the project?
So that's a good question. I was checking kind of what was in the 25 tons earlier today. About 10 tons of it were sort of concrete and steel, and you probably saw some of that in the slides. So avoiding materials like that, which tend to be, especially intense, or considering their impact very carefully as one makes design decisions. Certainly, I think windows on this job was about a ton. So windows and wall insulation are usually quite low embodied components, and so they usually win back their embodied carbon quite quickly. I think the projects we design now, we're much more conservative or much more controlled. I think it's a better way of describing it, in terms of the surgery we carry out, and demolishing a wall, moving it. We think very carefully about doing that before we proceed, and we tend to sort of, clients approach us with dreams of big extensions, and we often convince them over time to build much smaller extensions or no extensions at all. And I had having a conversation with somebody yesterday about that.
Nice.
Just using the space better. So that's sort of a slightly rambling answer to that.
Thank you. I'm going to read out a question from Reza. Reza, apologies if I've mispronounced your name. Do you know of any good resource that explains clearly to a client cost savings per investment, i.e. heat pump over a 1 to 30 year period?
I can't direct you to a specific place, but I mean, based on our own experience, heat pumps we're measuring now, we're getting coefficient of performance between 2.5 and 4. So you're certainly saving hundreds of pounds per year with a heat pump, if not thousands. And you're probably going to spend about £12,000 ish fitting one. So I kind of think over 30 years, you're very likely to see payback, probably in much less. Sure. Of course, each project's different, but I think heat pumps, a lot of us were really skeptical about them until a few years ago. But I think that's a technology which has finally matured, and if it's carefully controlled, I think can really, really do great things.
I would agree. Got a question from James. Hi, Bob. Thank you. That was really interesting. What experience do you have of using neutral, breathable insulation products like wood fiber or cork for retrofit internal wall insulation?
Yeah, so again, in the last 10 years, more products have come onto the market. Most of those, I think wood fiber might have been around when we did this, but I'm not sure we were even aware of it. And then there's insulating plasters have also appeared. So I think each project's different, but our natural inclination now is to try and use natural materials, ones which are less likely to cause environmental damage in their making and at the end of their life. And moving away from petrochemical insulations, I think there's a general shift, which is sort of industry wide, actually.
Yeah. Another question from Benjamin. They ask, I'm currently struggling to get any contractors to tender on installing energy efficient works, particularly underfloor insulation, not in London. Do you have any recommendations for how to persuade or guide contractors to do things that they see as too fiddly or complicated?
So it's I think we continue to share your challenge a bit. I mean, we know some contractors who we trust now. We've got some good relationships, and there are good people, but they're still relatively few and far between. So when we work with new contractors, we try and be really sort of open and engaging at the start. I think the way we produce information changed when we did this project. We produce information which is much more contractor focused. So we try and explain what we're trying to do in the first place, we listen when contractors tell us that it's difficult to do, and if that's true, then we try and find a better way of doing it. And we spend a lot of time on site working with them too. And those things are quite important because we plan those things into our fee proposals too, which means that sometimes we don't win jobs because our fee proposals tend to be a bit more than our competitors. But the construction bit is where it all stands up or falls down. Hopefully not literally. And that's the bit you've got to get right. You've only got one chance of getting it right, and so you've got to plan it really well, and you've got to work very well with your contractor. So we spend a lot of time with contractors. We're quite hands-on, and if it's easy and they're sort of making a fuss, we demonstrate that, and if it's hard, we change and we find an easier way of doing it. But it's hard work, definitely.
But worthwhile.
Yeah.
Peter asks, have you had any first-hand experience with clients shifting towards a more sustainable approach in projects as a result of COVID-19? Do you think COVID presents an opportunity to push sustainable design?
For me, sustainable design and low energy design is at least half of the wins are comfort and health generally. So some of you may have noticed from my background, I'm sat in a building which is hopefully nearing the end of a retrofit itself. But I've had the pleasure of living with ventilation and heat recovery for over a year now, and the air quality that yields is something I'm quite jealous of. And it's something I'm really keen to put into our office environment too, so that we can generally enjoy better air quality. But I've not had anybody approach us specifically with sort of COVID-related problems. But I think generally, well-managed ventilation is good for health generally, and I'm sure it's got some value related to COVID.
Sure. Another question from Graham, who says, our studio is very interested in a more low-cost, high-impact approach to retrofit, predominantly a result of project type and client budget, but also to democratize energy savings. What, in your experience, are the biggest gains to be made on a budget in your fabric first approach?
So I've spent 10 years thinking about this. And I think that the not amazing conclusion is window upgrades. I'm still astonished how many homes in London and the UK have got single glazing. And glazing technology has transformed in the last 15 years to the point where you can fit, I think, very authentic looking sash windows into historic buildings, but you can reduce the heat loss by up to 40% with windows alone, hopefully with a bit of ventilation thrown in there too. So I think windows remain kind of a bit obvious, but still people don't seem to sort of do them very well often.
Sure. Another question from Peter, a different Peter to one before. Says, thank you, Bob, for that. Have you seen a decrease in insulation thickness over the last 10 years? How much more space could you save now in comparison?
So we've looked at all sorts of insulants, and many of you will be aware of aerogel and thin insulations, which mean you can get super good U values without sort of inches and inches of insulation. I'm quite drawn by insulating plasters at the moment, which, because they don't involve sort of service runs in the way that a lot of dry lining systems might, they're more efficient. They also go on wobbly walls, I think, more easily, wobbly historic walls, and they fit the building physics of the surrounding, I think, potentially more effectively. So I think wood fibers and insulating plasters are sort of preferred approaches for internal wall insulation now, and we're a little bit less ambitious on U values now. We're I think we take a slightly more balanced view, and often we can do better with windows and perhaps not so well with internal wall insulation, and still end up with a really good result.
Another question from Consalo. I'm so sorry if I've mispronounced that. Hi Bob, thank you for your presentation. My current studio project is focused on retrofitting on a larger scale, redeveloping an old factory to become a cultural hub. I'm wondering if you have any other projects or precedents you did or know that effectively retrofit on a larger scale.
That's a good question. I'll remember a really good project as soon as this call's over. But I think the important thing is you're talking about a cultural hub. It's not domestic, so it's quite different in terms of its heating load. It will have sometimes lots of people in. They'll need lots of air. Your form factor of the building will be substantially different. I think actually bigger buildings are often easier because of form factor. So I'm sorry, I can't give you a silver bullet sort of reference. If it comes to me, I'll send it to Jason.
I'll send you some as well if I think of any. Can always think of like some of the larger cultural stuff that kind of not Western Wilson, Witherford Watson Man, or maybe Hayworth Tompkins have done.
However Tompkins have done that. The project in Kingston, facility, but that's a big project where I think they've done a pretty good job actually balancing architecture and a genuine low carbon retrofit agenda. That's a nice one.
Annalisa asks, with the decarbonisation of the electricity grid, I'm interested to hear if you think it is still worth aiming for the Nfit standards in terms of energy performance for retrofit.
So it's a good question, and I suppose I rarely recommend people go for Nfit. The house I'm sat in, I'm aiming to get that standard here. But I think that's because it was an appropriate project for it. I'm much more interested in sort of dwelling by dwelling, finding what's appropriate for each dwelling now. And Nfit is, it's almost passive house, and I think forcing that on some dwellings might be kind of injurious to their building fabric. So, but I would still encourage people to sort of push as far as is sensible with projects. So we don't want to just all aim too low and think that heat pumps are going to sort of save the day. We have to remain quite ambitious on both fronts, I believe.
Sure. The project or the case study you mentioned was 10 years ago. Do you think kind of planners have come a bit more on board with the kind of retrofitting techniques that you employed then and kind of more contemporary retrofit techniques that are employed today?
It's a bit of a mixed bag, actually. I mean, a lot of the stuff we did in terms of the extensions on that Hackney project, we wouldn't be allowed to do now, which I think is a real shame because I think there was something of a sort of quid pro quo on that, and I don't really believe we caused any damage. It was just a different way of doing it, and I thought there was kind of a charm in it, personally. I think planners have become a bit more worried that they're getting greenwashed, and I'm afraid to say that many conservation officers have become actually more resolute, and I think some of them are quite afraid of poor retrofit, and that's quite reasonable because there's been quite a lot of bad retrofit. But to sort of tar the whole approach with kind of the same brush is a real shame, and I really think planners and conservation teams need to sort of up their game, and I think local authorities need to write some more proactive guidance that considers retrofit, because at the moment most planning policy doesn't really have much to say about it, so it becomes a bit of a difficult conversation.
So there needs to be better guidance towards councils for full retrofits.
Yeah, I think they really need to own it and drive it, and not just sort of be the person at the end saying, I don't know about this, it looks a bit scary. They need to be on top of it.
Sure. And I was wondering, say if you kind of had a tabula rasa, not tabula rasa, kind of free reign to do the retrofit that you wanted for that project. What didn't you achieve that you wanted to achieve? If anything, of course.
I mean, I think for what was on offer at the time, we got out of it like so much more than you might ever imagine to do from a normal project. I mean, it changed what we did, changed the sort of trajectory of the office, certainly the trajectory of what I do, in a way which is very unexpected. But I'm really glad we've done that. So there's not many projects one does which have that impact on you. So I think it gave us so much more, and we continue to sort of go back and continue to discuss how it performs with the client. And in fairness, most of the projects we've done since then, we have that sort of relationship, and that's a really nice thing to have. To have that great relationship with clients like that, it makes every day a pleasure.
Sure. So I want to say to anyone in the audience, like if you want to unmute yourself, you're more than welcome to do that. I can see some of you have got your camera on. I don't know if you're trying to say hint at me that you want to unmute. I'm looking at Ben there. Sorry. I was wondering, Bob, if you had any questions for the audience as well. Like you kind of alluded to some within your presentation, but if you have any as well, do share.
Yeah, I wasn't expecting that. I mean, hopefully, the fact that you're listening, you've joined today, means that you're interested. But I suppose I hope that you're all interested in taking up kind of the retrofit challenge. For a long time, it seemed like many architects weren't very interested. I think that is changing now, actually. The subject is seen as a little bit more kind of acceptable as an architectural proposition. For a long time, I think it was seen as sort of a bit of a strange thing to do, and we felt quite sort of isolated doing it. But I encourage you to take it up and fight, please.
With regards to the kind of conversations you had with clients 10 years ago, compared to now, what would you say has been like the marked difference when raising the topic of kind of deep retrofit?
I mean, they raised the topic with us now, which is great. So 10, 15 years ago, it felt like we were smuggling insulation in at the dark of night, whereas clients come to us and ask us about Passive House, and are often understand a bit about fabric first, and that's a really good place to start from. So I think the message has got out to the public, and homeowners are keen to sort of take up the mantle.
Sure. Great. I can see it's 1 minute 2, and I'm conscious that these things are meant to run from 1 till 2. So I do want, if anyone has any last minute questions, do put them in the chat now. Now's your chance. But failing that, I was going to say thank you very much to Bob and to this massive audience which you've had today, which has been a real